Today we're going to take a look at improving JavaScript performance and user interactions. What we see here is a demo as part of the web.dev Learn Performance course. It is available online. You can find it on this URL and you're able to view the source code on Glitch using this URL. I will include them in the description. Okay, so let's get started. For this demo, I will be using mobile device emulation and I will be slowing down my CPU by 4 times, which you can find under the performance panel. The first demo serves to illustrate the issue of long tasks. And long task is a task which takes more than 50 milliseconds to complete and may result in a slow user experience. In this demo, we've got a search box, we've got this animation which is running repeatedly, and here we've got the search results which show up over here. If I type in the search box, it will filter the results and output similar matching names. As you could see, while typing, the animation is completely jammed and it takes long to update the UI. Let's take a look at how this appears inside our trace. I will disable the animation. One sec, I'll get it started one more time. I'll disable the animation to avoid getting too much noise inside our trace. And once again, I will type into the text box. The first thing which stands out is this long interaction, keyboard interaction, and another one over here. As you could see, so this is probably one key up. Yes, so one key up. It creates this anonymous function, which in turn calls filter results and render list, which we'll be taking a look at shortly. We've also got recalculate, style, layout, and eventually paint. All this is combined together in a single interaction. And this probably is one key press. Over here, since I press the keys in rapid succession, we've got a number of key up events. These are all chained together or combined together for one single interaction or treated as one single interaction. This is the source code for our file. I won't go through in detail about the top section, but basically we are fetching and sorting data based on some string similarity. But what interests us mostly are these functions over here. So the filter results, which is showed up in our performance trace, the render list, and over here we've got our event listener on key up. The first thing we're going to do to improve interactivity is to use set timeout to yield to the main thread. Whenever we use set timeout, the callback function is added as a new task to the task queue, which means that the main thread has or the browser has a chance to paint any visual updates to the screen before it executes the callback. The simplest way to do that is to wrap our CPU-intensive tasks with a set timeout, which would look something like this. So what will happen in this case, on key up, it will set the value, then it will queue a task, which will filter the results and render the list. Let's see how this looks. Okay, we're on to the next demo. First, let's see how it feels. So I don't know if you could notice that, but when you press one character, it is removed immediately. But when you do a few in succession, once again, it gets stuck. Let's disable the animation and record the performance trace and see what we've got. All right, let's see. So, we could see that the interactions are broken down a little bit. So this is probably the first key press. Let's see if it matches the screenshots. Here's the first key press. So this will be something here, exactly this one. So we've got this tiny interaction. And this is because immediately after the user pressing the character, it appears on screen almost immediately. This is because the filter results come afterwards, which is what we see over here. So at this point, we're not filtering anything, we're just outputting the character which the user input into the text box. Over here, we call the CPU intensive work, the filter results, and the render list. The issue is that if the user presses a next character while it is processing this, as what happened over here, we incur a significant input delay, which is this ticker from here to here, before it can start processing our task. Once again, here it is going to update the next character to the screen. We've got our set timeout, timer fired once again, and it starts with the next character. So as you can see, when we've got single character, it appears quickly, but we still have these huge long tasks, and when pressing multiple characters one after another, we still have the issue. Let's see if we can improve that further. We can break the long task into two separate tasks by yielding between them. We could do that using set timeout. However, this will result in some nested set timeouts, which maybe are not so readable. It would look something like this. Or else, what we could do, we could use function yield to main. We're going to create a function which returns a new promise that resolves on set timeout. This gives us some much better ergonomics when having multiple yield points. So that would be something like this: set timeout, resolve 0. So what this would give us, a promise which is going to resolve on set timeout, and that will invoke, that will yield to main whenever we call this function. What you need to keep in mind when using this is that we need to change our functions to async, and we can do something like this: await yield to main, and here await yield to main. Come on. Yep. That would look something like this. So over here we've got two yield points, one before filter results and one before our render list. Okay, we're on to the next step of the demo. First, let's see how it feels. Feels faster, but you could still see that it is getting stuck, especially looking at the animation. But even while I'm typing, I could feel the significant lag. Let's take a look at our performance panel once again. I'll clear this out. Start our trace. Okay, let's see what we've got. So we still have some long interactions over here. This is our first input, paints immediately, similar to before, fires the render list. So here probably got the filter, yeah. So we've got the filter results in one task, the render list in a separate task. Then it updates the UI. Over here we've got the input delay, similar to before, because it is processing quite a long recalculate style and layout. And what happens over here, so we've got our filter results, and before that somewhere we should have our filter results, and after that we should have our, let's zoom out a little, a separate task, and we've got layout styles and paint, and then we've got the render list. So between filter results and render list, the browser was able to paint to screen. This is again an improvement over what we had before, but we still have these long tasks over here, long tasks related to style, and when the user presses a few characters in quick succession, it feels quite laggy. Let's see how we can take and improve this even further. We can improve the performance by reducing the time spent inside filter results and breaking it down into smaller tasks. Let's take a look at what it does. So filter results itself, we've got first a relevance array where we're calculating the relevance score based on a string similarity, so how similar each item is to the user input. And then we're calling sort. Let's take a look at sort. So sort, we're using an insertion sort algorithm here, which is probably not ideal, but for the purposes of this demo, helps us illustrate the issue. And what we can do inside our sort, we can yield periodically. So we could yield after X number of elements, or in our case, we will yield every 50 milliseconds. To do that, we will set a timer, or like take the current timestamp, check if 50 milliseconds have elapsed, and if they have, we will yield to main. To yield to main, let's put this here immediately. So let's get the current time. So let deadline equals performance.now. So the current timestamp plus 50 milliseconds. Then what we will do inside here, inside our loop, we will check if performance.now, so the new timestamp, is greater than the deadline, so the deadline has elapsed, then we will update the deadline to be equal to performance.now. So we'll update it by 50 milliseconds forward, just pushing it 50 milliseconds forward, and await yield to main. So we create a yield point over here. If not, it will continue processing the loop. So it will process the loop once the deadline has elapsed, yield to main, and then continue processing. Let's see how it feels. Okay, let's do a quick search. It still feels a bit laggy. Even if you look at the animation, you will notice that it sometimes gets stuck. Feels much faster than the previous ones, but still feels a bit laggy. Let's see how it looks in the performance trace. Now input one character first, and then 3 quickly. This is probably the first character. Yep, and got over here. Once again, it paints immediately. And then we've got our long task over here. And over here, when I pressed in rapid succession, we still have a number of long tasks. But as you can see, the sort is broken down into a bunch of smaller tasks. This one takes just over the 50 milliseconds, but overall, they're all approximately 50 milliseconds, which is what we were hoping for. The good thing is that if the browser needs to paint in between, it can do that, or even handling critical user input, it could do that in between processing the sort. We still have quite a long render list. Here, quite a long task related to style and layout. So let's see if we can improve those. We improved the filter results. Let's see how we can improve render list. So render list is creating the HTML and updating the DOM. And this is causing this recalculate style and layout because we are updating 500 elements at one go. What we can do in this case is batch our updates in smaller chunks. So let's do that. Let index equals 0. We'll create a batch of 100. So we're going to output 100, which is enough to fill the scrollable area. And then we will yield to main after the first 100 and then continue processing 100 at a go. Okay, so while index is less than data.length, so until it reaches the end, we'll push our for loop in there. And instead of 0, we'll start at index. And over here, we'll see math.min data.length or index plus batch size. So as we are iterating through our list, if we reach the end, obviously we want it to stop. This will leave commented out for now. And what we want to do reaches the limit, we increase our index plus equal to batch size. So we'll start at 0. Next one is going to be 100. And here await yield to main. One small change over here. Instead of updating all the HTML at once, we will use root.insert adjacent HTML before end and our HTML string. Yeah, so that looks all right. Let's check how it feels. Okay, so the UI updates almost immediately, I would say. The animation barely lags. But the results come in a bit later, as you can see over here. Let's hide our animation. We test it one more time. Sorry, I forgot to enable this. Okay, so looking at the performance panel, there's still obviously a lot of work being done, but we could see our tasks are much smaller, giving the UI a chance to update in the meantime. Our filter results marginally over the long task limit, but our interactions are now much faster. One thing that is missing from our improvements is the use of a debounce function. A debounce function will only take the last call to that function, to the callback inside that function, and discard the previous ones. So if we've got our input field and we are inputting in quick succession 3 characters, it will only take the last character, and for us this is perfect because the search results, we are only interested in the ones after the last input. Let's see how we could add a debounce function. So a debounce function, at least the simplest implementation, would use a set timeout and a clear timeout. So we've got our key up event. We will set timeout, delay it by 200. Yeah, we'll do something like this. So let timer equal 0, clear timeout timer. So as soon as we have a key up, we'll clear the timeout, then we'll call the set timeout and we'll throw in there the rest of our code. So it will only fire this after 200 milliseconds if there was no user input in the meantime. We could also add some UI elements to indicate that the search results are still loading. So get element by ID, search results dot last list dot add loading. So here we're going to add the loading. Once it has finished, we will remove loading. So this is a very simple implementation. We're just going to add this class loading, which will maybe add an opacity or a blur effect or something like that. Okay, let's take a look. All right, let's go to our search text box and see how it feels. So as you can see, we are setting the opacity to indicate that it is loading. It feels fast as well, so as I'm typing, the user input comes immediately. The animation barely lags at all. Let's hide the animation, check the performance panel one last time. Let's check the performance panel. Feels much better already. And as you can see, it looks much better. We still have some tasks which take a bit of time. I mean, here it's just 50 milliseconds, but the user interactions feel intuitive and are under 200 milliseconds, which is a huge improvement compared to where we started. I hope you enjoyed the demo. I enjoyed creating them and going through them. Feel free to get in touch if you have any questions or feedback. Have a good one.